As discussed earlier, the forces that hold atoms in a compound are chemical bonds. In addition to these strong bonded forces, relatively weak force also exists in between the molecules, which are called intermolecular force. The bonding and intermolecular forces of hydrochloric acid, as shown in figure. Intermolecular force figure. It requires about 17 kJ energy to break these intermolecular force between 1 mole of liquid hydrogen chloride molecules to convert it into gas, whereas about 430 kJ energy is required to break the chemical bond between hydrogen and chlorine atoms in 1 mole of hydrogen chloride. Dipole-dipole interaction. Most important long question in board. All the intermolecular forces, which are collectively called van der Waals forces, are electrical in nature. They result from the attractions of opposite charges, which may be temporary or permanent. The unequal sharing of electrons between two different types of atoms make one end of polar molecule slightly positive and other end slightly negatively charged. As sheer pair of electrons is drawn towards more electronegative atoms, it is partially negative charged as chlorine in hydrogen chloride. The other end automatically becomes partially positive charged as shown in figure. Here is the definitions of dipole-dipole interaction, which is not present in the book. The forces of attraction present between partial positive end of one polar molecule and partial negative end of the other polar molecule is called dipole-dipole interaction. Here is the explanation. When partial positive and partial negative charges exist at different positions in a molecule, the adjacent molecules will arrange themselves in such a way that negative ends of that molecule comes near to positive end of the other molecule. It results in a net forces of attraction between oppositely charged end of two adjacent molecules. These attractive force are dipole-dipole interactions as represented in hydrochloric acid. Here is the figure of hydrochloric acid. Hydrogen bonding. What is hydrogen bonding? This is also very important long question in board. Hydrogen bonding is a special type of intermolecular force present in the permanently polar molecules. This bonding can be considered unique dipole-dipole attraction. This force of attraction develops between molecules that have a hydrogen atom bonded to a small highly electronegative atom with lone pairs of electrons such as nitrogen, oxygen and fluorine. The covalent bond between hydrogen atom and other atoms becomes polar enough to create a partial positive charge on a hydrogen atom and a partial negative charge on the other atom. The small size and high partial positive charge on the hydrogen atom enables it to attract highly electronegative atom of the other molecule. So, partially positively charged hydrogen atom of a molecule attracts and forms a bond between with the partially negative and charged atom of the other molecule. The bonding is called hydrogen bonding. This forces of attraction is represented by a dotted line between the molecules as shown in below this figure and also this figure, and these lines dotted line that we ask in this. Hydrogen bonding affects the physical properties of the molecules. Due to this, boiling points of the compounds are affected greatly. For example, boiling point of water 100 degrees Celsius is higher than that of alcohol 78 degree because of more and stronger hydrogen bonding in water. The important phenomena of floating of ice over water is because of hydrogen bonding. The density of ice at 0 degrees Celsius into 0.917 gram cubic centimeter is less than that of liquid water at 0 degrees Celsius 1.00 gram cubic centimeter. In the liquid state, water molecules move randomly. However, when water freezes, the molecules arrange themselves in an order formed that gives them open structure. This process expands the molecule that results in ice being less dense as compared to water.